Hello, and welcome to this Xilinx Quick Take tutorial titled Getting Started with the Vivado Integrated Design Environment, or IDE for short. The agenda is going to start out with a demonstration of the Vivado IDE using an example design. We'll first review the advantages of using the Vivado project flow in conjunction with the IDE. The project flow enables a whole host of advantages, including full process configuration, management, and control with the Flow Navigator. All of the project summary and settings are stored and presented each time the project is opened. There are interactive IP and block design capabilities within the IP integrator. Very robust source and constraints management system throughout the flow in Vivado. There's an interactive I/O, pin, and clock planning environment, as well as full implementation, run control, and management. And all throughout the flow, there's a very comprehensive capability to analyze and visualize the design from multiple perspectives. The Vivado IDE can also be used in non-project mode or by opening design checkpoints. There is a reduced set of IDE capabilities. There's no Flow Navigator or project summary, settings, etc. But the environment can be used very effectively for design analysis and visualization at various points in the design flow, including after implementation. Constraints analysis and modification. You can write out constraints into a new constraint file for the next time you run through the flow. It can still be used for IP and block design configuration, as well as pin planning. And debug logic insertion are some examples of how you can use the interactive design environment in conjunction with the non-project TickleScript flow or by opening design checkpoints. Let's get started by opening the Vivado IDE. All of the tool and tool features associated with the Vivado Design Suite are integrated directly into the IDE. Its primary purpose is to facilitate the Vivado project flow. However, it can be used at certain points during the non-project flow for design analysis, constraint assignment, IP configuration, pin planning, etc. In this example, I've opened up one of our configurable example designs targeting a Kintex UltraScale device with an embedded microblaze design on one of the Xilinx evaluation platform boards. Notice that when a project is opened, I'm presented with the project summary, which details the status at the current stage of the design I'm in. Notice here synthesis and implementation are complete, and I'm presented with the resulting status in terms of timing, power, utilization, etc. And because I'm in a project, I'm presented with the Flow Navigator here on the left. The Flow Navigator allows me to initiate and control the entire design flow. I can add sources and configure IP, create block designs with the IP integrator, simulate the design, synthesize and implement the design, or generate bit streams, all within a touch of one button. When any of the run buttons are clicked, the entire flow is initiated and run up until that step. The entire design flow is tickle-based. As I select commands, the underlying tickle commands are run, and they can be displayed in the tickle console. So when I select the Generate Bitstream command here, notice the resulting tickle command is displayed in the console. Also up in the upper right-hand corner, the run status is displayed, telling me it's running right bitstream. I'll go ahead and cancel. Tickle commands and tickle parameters can be entered into the tickle console at any point during the design flow. And as you can see, the status of the commands is displayed in the tickle console as well. In this case, the design has been run all the way through implementation. All of the messages associated with each of the commands within the flow are consolidated and displayed in the messages view. Some of these messages have cross-probing capability directly back to RTL or XTC constraint files. The log files for simulation, synthesis, and implementation are also available within the log window. And a default set of reports are generated for each stage of the design flow. And finally, the design runs view displays design run status. Vivado does allow you to generate multiple runs in order to try different strategies for synthesis and implementation. Now let's talk about some of the project-based features within the IDE. Notice the project settings for each of the design steps, including simulation, synthesis, implementation, and so forth, are all presented, and these can be stored, so any custom configuration for each project is stored within the project for future use. The Add Sources command allows me to add the various types of sources to the project for compilation within the flow. This includes sources from some of the peripheral tools, such as the high-level synthesis tool and the system generator. The Vivado Sources view allows you to manage and configure the various sources that have been added to the project. The design hierarchy is compiled on the fly and displayed to ensure that the project gets assembled correctly. Double-clicking on any of the right-enabled text sources will bring that text file up in the text editor. The project allows you to configure and manage multiple constraint sets that can be applied to multiple runs or multiple parts of the design flow. And also you can configure various simulation sources, including test benches for your design or portions of your design under the simulation sources hierarchy. Xilinx provides architecture-specific language templates for Verilog, VHDL, and XTC to ensure that your RTL and constraint files are crafted in the most efficient formats. And then there's the IP catalog. The IP catalog contains a categorized list of all of the Xilinx IP subsystems, as well as links to IP from some of our third-party partners. The catalog provides a categorized list of all the IP. From here, any of the IP can be configured and instantiated into your design. Custom IP can also be packaged and added to the catalog. Different things can be packaged into IP, including existing Vivado projects, block designs, or custom directories of RTL files that you may want to package into IP. AXI peripherals can also be created to help you interface your IP within the IP integrator. Once the IP has been packaged into a repository, the repository can be accessed from the IP catalog. The next big feature is the IP integrator. I can access it by either creating a new block design, or in this case, since it is an embedded design, it's got a block design already created. Notice you can see the symbolic representation of the various IP and IP interfaces in my design, and they're connected through standard AXI protocol. All of these connections can be made with a simple click of a button or by using the automated connection assistance available within the tool. The IP integrator allows me to easily configure the IP and connect the IP to create IP subsystems for use in my design project or other design projects. There are plenty of other quick take tutorials describing the features and the use models of the IP integrator. The next step in the flow is simulation. Notice if I click on the simulation settings, I can configure the tool to interface directly with any of the third-party simulators that are available, or of course with the default Vivado simulator. The Run Simulation button allows me to launch simulation at the various points in the flow. Notice there's behavioral for pre-synthesis, after synthesis, both functional and timing simulation, and after implementation, both functional and timing with the true SDF delays from place and route. Notice here I've launched the Vivado simulator, and I've got access to a full simulation and debug environment within the Vivado IDE. Vivado also allows me to elaborate my RTL design prior to synthesis. This stage also helps me introduce a unique feature of the Vivado design environment, and that I can open the design at various stages of the design process to perform analysis or various design tasks. Notice here I've opened the elaborated design, and I'm presented with a top-level schematic of the entire design. I can navigate through the schematic to explore my design, or I can run a series of design reports, such as the methodology DRCs, to ensure that my design is compliant and optimal for synthesis and implementation. I can also perform I/O pin planning tasks early in the design prior to synthesis. Notice here I've invoked the I/O planning layout, which presents views associated with I/O pin planning. This is also an excellent environment for selecting the I/O banks and bank configuration for the various memory interfaces in your design. The same interface is available after synthesis as well. Moving on through the flow, I can obviously configure and run synthesis, but after synthesis, I can also open the synthesized design to perform analysis or various design tasks. These might include I/O planning, timing constraint analysis and configuration, debug core insertion for use within the lab tools environment, and a whole host of reporting and design analysis tasks. I can also open the implemented design after place and route to analyze the fully implemented design. Notice here I can see the logic dispersed within the device, and I can even turn on the routing to see the actual interconnect of the device. Notice here I've selected the worst case timing path, and you can visualize its path across the device. There are also a whole host of quick take tutorials discussing the various analysis and design implementation techniques that are available within the Vivado IDE. And finally, after implementation, the last step in the flow is to generate a bit stream and to configure the device. This can all be done directly within the Vivado IDE or within the standalone Lab Tools environment that can be used within the debug lab. So hopefully you can see how tightly integrated all of the features and functionality of the Vivado Design Suite is within the Vivado IDE, which works very, very well in conjunction with the Vivado project. Now, when using projects, a directory structure is created on disk to store the various configurations and optionally the IP, block designs, and sources, as well as results for the design project. As mentioned earlier, most of the features within the Vivado IDE can also be used in non-project mode. Here you can see I've got a design being compiled through synthesis and implementation in the Vivado Tickle Shell. The design in memory can be opened in the Vivado IDE after any of the design steps. Notice here that after the design has been through routing and several reports have been generated, I'm going to use the start GUI command to open the Vivado IDE. And you can see that the implemented design has been opened for analysis. Notice I don't have a flow navigator, project summary, or any of the project-related features, but I do have access to many of the analysis and reporting features to help me analyze the design. And by typing the stop GUI command in the Tickle console, we'll close the IDE and bring me back to the Tickle shell. The same environment can be used to open and analyze design checkpoints that were created at any stage of the design process. I'll use the open checkpoint command, and notice I've got 3 design checkpoints that I've written as a part of this example script. There's one after synthesis, placement, and routing. I'll open the routed one. And as you'll see, I have access to the same analysis and reporting capabilities that I had with the design in memory. So that was a quick introduction into the features and functionality of the Vivado IDE in both project and non-project mode. The Design Flows Overview Design Hub within the Documentation Navigator will direct you to a lot more collateral to help you get started with using the Vivado Design Suite. Thank you very much for your time.
Thanks for viewing this quick take. If you found this video useful, you might be interested in taking some of our more in-depth training available at xilinx.com/training. We feature a variety of courses, both live and online, intended to make you proficient with Vivado and its features. We look forward to your participation. Thanks again for making Vivado successful.